Good morning everyone. Today we are going to see mechanics of material in that unit 2 torsion and springs. So coming to the introduction of torsion. Torsion is a twisting moment. We call it as couple or torque. That is, here the shaft is subjected to a rotation. That is, at the end of the shaft the subject it going to subject a twisting moment. That is, a force is applied perpendicular to the longitudinal axis. So that force make the shaft to rotate. So this term is called a twisting moment or a torque. So there is a torsional equation T by J tau by R equal to C theta by L. In that, tau is the shear stress, R is the radius, T is the torque, J is the polar moment of inertia, and C is the modulus of rigidity. And theta is the angle of twist, and L is the length of the shaft. Coming to a problem, you take this example: a circular shaft transmits 85 kilowatts power at 200 rpm. So calculate shaft diameter if the shear stress is 50 meganewton per meter square. So in the given data we have to do one unit conversion, that is the shear stress is given in meganewton per meter square. So that should be converted into newton per millimeter square. Then coming to the solution, we know power equal to 2 pi nt by 60. So substitute that and you get a torque in Newton meter. You convert the torque into Newton millimeter by multiplying into 10 power 3. Then we know a basic torque formula pi by 16 tau d cube. So in that you substitute the calculated torque value and find the diameter of the shaft as 74.4 mm. Coming to the second example. So this problem having the given data as the diameter of the shaft and the allowable twist 3 degree and the length of the shaft and the modulus of rigidity as C equal to 1 into 10 power 5 Newton per millimeter square. So we are going to start from the T by J concept because the theta is given in the problem. So that theta should be converted into radians by multiplying it by pi by 180. So you are going to have 0.05 radians. Now coming to the solution, use the formula T by J equal to C theta divided by L. Substitute all the values. You know the value of J, that is pi by 32 d power 4. Substitute in that and get the value as 20.3 into 10 power 6. Substitute in the T by J formula and the only unknown is torque. So find that. So it's going to be 67.6 kilonewton meter. Then coming to the third example, it's a hollow shaft going to transmit 300 kilowatts at 80 rpm. If the shear stress is not to exceed 50 meganewton per meter squared and diameter ratio is 3 by 7, find external and internal diameter if the twist is 1.2 degree and length is 2 meter. Assuming maximum torque is 20% greater than the mean, and take C equal to 80 giganewton per meter squared. So as usual, do the unit conversion for shear stress and theta and the length, everything. And here they have given d by d ratio, that is internal diameter to external diameter is 3 by 7. And they have given one more condition, 20% exceed, that means T max equal to 1.2 T mean. Likewise you have to take, and the modulus of rigidity as 80 giganewton per meter square, that should be converted into Newton per millimeter squared. So the question is external and internal diameters. So as usual, you are going to start from the power formula, that is P equal to 2 pi nt by 60. So substitute in that, find the torque value, this is T mean. So once again do the calculation for T max, that is 1.2 T mean. So you find the T max as 42.96 into 10 power 6 Newton millimeter. Then use the first case, that is basic formula for torque. T max equal to pi by 16 tau d power 4 minus d power 4 divided by d. So in that you substitute and find the values of capital D and small d. So that is going to be 165 and 70. Then you coming to the second case using the formula T by J concept, that is T by J equal to C theta by L. So in that J equal to pi by 32 d power 4 minus d power 4, substitute and find the values of J and actually that is in this d power 4 and d power 4 both are unknown, so you keep it as unknown values and substitute in the t by j formula. So finally you got d, capital D as 154 and the small d as 66 mm. So from the two cases you select the bigger values, that is the final answer is capital D equal to 165.4 mm and small d as 70.8 mm. And coming to the second topic, spring. We know spring is a element used in the brakes, clutches, watches, toys, vehicle and machine foundation, railway garages, motor cars, scooters and motorcycles. It going to give the cushioning effect for the arrangement. It absorbs the shock and vibration, and it give the retraction effect for the applications. Likewise, we use the springs for day-to-day life. And it has a types as laminated or carriage or leaf spring and helical spring. The helical spring is furtherly divided into open coil and closed coil. Open coil is also called as compression spring, and closed coil also called as the tension or extension spring. Coming to an example problem, a closed coil helical spring is made up of steel rod having diameter 10 mm and mean coil diameter of the spring is 120 mm and the number of complete turns is 12. The modulus of rigidity of the material of the spring is 0.86 into 10 power 5 megapascal. If this spring is subjected to an axial load of 200 Newton, calculate axial deflection, maximum shear stress. So as usual, do the unit conversions and use the formula delta equal to 8w d cube n divided by c d power 4. Substitute the value and find the deflection as 38.57 mm. And coming to the second equation, shear stress of the spring, tau equal to 8wd divided by pi d cube. Substitute the value and get the value as 61.12 Newton per millimeter squared. So we can find deflection and shear stress by using the direct formulas. That's all today. Thank you.